Hello everyone. Today I'm going to be talking about programming. Uh, Specifically today I'm going to be talking about WPILib in Java, used for first competitions and the FRC. So first of all, what is WPILib? Well, robots have two main parts of them. They have hardwiring, or hardware, and their programming, or the software. This presentation will go over the software and the library needed to code robots in the first robotics competition, FRC. What is WPILib again? It is the official standard software library used by FRC teams to write code for robots. It is used everywhere from motors to sensors and can create code for drivetrains and controllers. The best thing about it is it's all provided for free online, and the WPILib docs has all the information and documentation necessary to create robots from scratch. This is the next step up from FLL, or First Lego Leader, creating code instead of using preset programs in Legos. Well, how does WPILib work? WPILib is based in two languages, Java and C++, and requires a fully functional IDE to access the classes and methods provided by the library. The most common IDE used for FRC is VS Code Studio, which can be downloaded at this link here. It is user-friendly and easy to use, but also powerful enough for the robot. VS Code Studio can also run languages outside of Java and C++, such as Python and JavaScript, if you would like to experiment. Well, how does WPILib work? First, there are three parts to programming an FRC robot. You have commands, subsystem, and miscellaneous classes, which contain the container, main, and constant classes. The first subset is the commands classes. These classes provide the methods necessary, but not already provided by WPILib, to command the robot to do specific actions based on set parameters. These can override existing methods provided by WPILib, and they are used by the subsystems classes to carry out the robot's functions. For example, arms, controllers, balancing, and motors. These methods are not called in commands, but merely declared and set. This is an example of a arm command. It basically declares and initializes the arm commands and calls the set point and set tolerance, and also the enable continuous input commands. When this class is called, it will run these and initialize the arm commands. Next, we have subsystems. A subsystem is an abstraction for a collection of robot hardware that operates together as a unit. It calls methods from WPILib that talk with the robot's hardware to move, function, and return data that can be used for other functions in the robot. It encapsulates the robot's hardware, and for example, an ARM system using methods written in the command classes, it uses those methods to control the robot. This is an example of a hatch subsystem using double solenoids from the WPILib documentation. At the top, we import everything necessary, and we also create the class and the variables necessary. There are only three methods in this subsystem. The example provides command base, the grab hatch command, the release hatch command, and the initial sendable. And it publishes the solenoid state to telemetry. Next, we have the miscellaneous classes. The first being container. This class is where the bulk of the robot should be declared. And since command base is a declarative paradigm, very little robot logic should actually be handled in having robot periodic methods other than the scheduler calls. So what this means is basically the container only declares all the robot logic, but very little of that logic is actually handled in the container, but rather done through the command and subsystems. They are declared here and they're used. The structure of the robot, including system commands and button mapping, should all be declared here. This is an example of a container that configures button bindings on a drive controller. So let's say we wanted to use an Xbox controller to drive our robot. We create 3 driver bindings for each of the 3 joystick buttons. Next, we have operator bindings, joystick button, and POV buttons. In the driver bindings, it calls the mRobotDrive method, and that just drives the robot. In the operator bindings, we have the grabber subsystem, the ARM subsystems, the operating controllers, and the ARM commands that are being called. This method defines our button to command mappings, and buttons can be created instantiating a generic HID or one of its subclasses, such as the joystick. At this website for the WPILib documentation has more in-depth information and guides on the step-by-step process to WPILib. More videos will help with each aspect of FRC programming. Make sure to check out the documentation. It is very user-friendly and easy to understand, assuming basic Java knowledge is acquired. So with that, I'd like to thank you for watching, and if you have any questions, be sure to leave a comment. Also, like and subscribe if you enjoyed. Again, thank you for watching.